Good morning everyone. In today's video we will be discussing about the preparation of aldehydes and ketones. The first preparation what we are taking is oxidation by oxidation of 1 degree and 2 degree alcohols. We know that depending upon what oxidizing agent we are using, you will get from the alcohols either aldehyde ketone or acid. Like for example, if I start with 1 degree alcohol, 1 degree alcohol say RCH2OH, and if I try to oxidize them, the first product is aldehyde and the further oxidized product is acid throughout the same number of the carbon atoms. If I start with the 2 carbons, I'll get 2 carbon acid. That is for 1 degree. And the reaction will not stop here if we are using strong oxidizing agent like acidified potassium permanganate or potassium dichromate. If we are using these strong oxidizing agents, then from alcohol, 1 degree alcohol, you will get acid directly. Now in case we want to stop the reaction at aldehyde or at ketone, then we'll have to use a mild oxidizing, slightly less strong oxidizing agent. Now in this itself, if I take 2 degree alcohol, I'll get ketone. 2 degree alcohol will give you ketone. Okay, now suppose I take this one, say primary alcohol I am taking. I want to stop the reaction here at RCHO, that is aldehyde. Then we will be using CrO3, chromium oxide, as the oxidizing agent. It will stop here. And in case I am taking here RCH, say R-OH, that is a 2 degree alcohol, and chromium oxide as the oxidizing agent, then we will get ketone as the oxidized product. Then you will not get acid. Okay, if you are using these strong oxidizing agent, then you are getting acid. Then suppose I take this say R, CH, say I use a double bond, and I am using of course a primary alcohol, and I want to prepare aldehyde. Then there is another oxidizing agent, PCC, that is pyridinium chlorochromate. Pyridinium chlorochromate. If we are using this, then nothing will happen to the double bond. It will remain as such, and instead of alcohol, now you will have acid. And how do you prepare this PCC? It's basically a complex that is obtained by mixing this with pyridine and HCl. Now what is pyridine? Pyridine is a heterocyclic ring. Instead of carbon, there is one nitrogen atom. Okay, so this is strictly used for aldehydes, not for ketones. Clear? So if you want to prepare aldehyde or ketone, then we'll be using these oxidizing agents. 1 degree will give you aldehyde, 2 degree will give you ketone. And if you try to carry out the oxidation by the previous methods only for tertiary alcohols, by using these strong oxide, it will not undergo. Tertiary alcohols do not undergo oxidation easily. Okay. Second method to prepare aldehyde and ketone. See, initially we are discussing those methods which are common for both aldehyde and ketone. The second method is dehydrogenation of alcohol. Now I've just written it because it is already discussed in my previous videos, that is in alcohol. If we take 1 degree alcohol using copper or silver 573 Kelvin, you will get aldehyde. If you use 2 degree alcohol in the presence of the same oxidizing agent, then dehydrogenation means hydrogen is removed. How will you remove hydrogen? 1 H from here, 1 H from here, that means you are getting aldehyde. Similarly here, 1 H from here, 1 H from here, that means you will get ketone. If we use 3 degree alcohols, then there is OH, but there is no H over here. So it will not be losing hydrogen. In fact, it will lose water. So what will happen here is you will remove OH from here and H from the neighboring carbon. Here or here the product will be same. So you will remove water from it, and 573 same. This is same for all. You will get this alkene. Okay, this will undergo dehydration rather than undergoing dehydrogenation. So these two methods are clear. These first two methods are the repetition we have already discussed in alcohol chapter. The next method is from hydrocarbons. So in this further there are two. First we are taking from alkenes. From alkenes they can be prepared by ozonolysis. Again, it's quite simple. Suppose you are taking some alkene where it is symmetrical. Suppose I am taking a symmetrical alkene. Say I have taken but2ene. This is reaction with ozone in the presence of zinc and water. So first thing is ozone is going to add on here. So when it gets added on, you will make a structure. You will break two bonds and you are going to add ozone in this manner. Break both the bonds which are there between the carbon atoms and add ozone. Add ozone in the manner like this, a hut manner. Then in the presence of zinc it is going to break. So you will break like this. In the form of Y you are going to break it. So what is left over? You can just check here. This is one product and this is another product. What is this? CH3CHO. Same way CH3CHO. That means what you are getting is 2 moles of CH3CHO. This is just for writing the product. But otherwise, you can just say, looking at the structure, you can say what product will be obtained. Wherever there is a bond, break the double bonds, add O either side. That is the product. Okay, so let's take some more examples of what aldehyde ketone will be obtained from alkene. Now suppose you have these alkenes and you are carrying out the ozonolysis. So ozone in the presence of zinc and water. How you write down the product? I told you the simplest way. In ozonolysis, break the two bonds, add O here, add O here. So what is this? This is HCHO. That means you are getting 2 moles of HCHO, 2 moles of formaldehyde. Same way here, break the two bonds, add O here, add O here. So what is this if you read it? CH3COCH3. Likewise on the other side, you are having CH3CHO. Here break the two bonds, add O here, add O here. That means you are having 2 moles of acetone. So that means by ozonolysis you can prepare aldehyde as well as ketone. Another method is from alkynes. Even this is done a part of class 11. Now suppose I take this one, alkyne, that is I am taking the basic one, ethyne. If you add water to this in the presence of HgSO4, H2SO4 at 60 degrees Celsius, since it's a symmetrical alkene, you needn't think much. You will just add water to it. When you add water to it, the electrophilic addition will occur and triple bond will change to double bond and you will get this vinyl alcohol. It is enol. This is not stable, so there will be tautomerism in it. There will be tautomerism in this and it is going to rearrange because this is quite unstable. This vinyl alcohol, the product which is obtained is vinyl alcohol. It's unstable. So H goes here, makes this as H3 and the valency is disturbed now. So this double bond will shift here and what you are getting is CH3CHO. That is acetaldehyde will be obtained. Acetaldehyde will be obtained in this case. Now in case you are taking some unsymmetrical alkene, let us take that example now. Say if I am taking propine, this one, if I am taking propine and I add water, same way, HgSO4 and H2SO4, 60 degrees Celsius. Now water will add as per Markovnikov's rule. It is unsymmetrical alkyne. So H and OH, this is the way the water will add on. and CH3COH. Now this becomes double and it becomes CH2. Okay, now this is again enol, double bond and all, both are there in it. So there will be, again, it's quite unstable, and this H will go here. When H goes here, it becomes H3. To complete the valency, this double bond will shift down. And so what you are having now is CH3, C double bond O and CH3. That means you get acetone. So to prepare acetone, to ketone. Okay, here aldehyde and this one is ketone. So by hydrocarbons also you can prepare. From hydrocarbons also you can prepare. That is, from alkenes and alkynes you can prepare aldehyde and ketone. So far we have discussed two methods. Basically, alcohol. From alcohol there were two: oxidation, dehydrogenation. Then from alkene you can prepare by ozonolysis. From alkyne you can prepare by hydration. It is acidic hydration. Basically, you are adding water in the presence of acid. Clear? Now we will take methods of preparation of aldehyde only. There are certain methods which are entirely different for aldehydes and ketones. So first we are taking in aldehydes Rosenmund's reaction. It's a name reaction, quite important reaction. Rosenmund's reaction. Now in Rosenmund's, basically what you are doing is acid halide is converted into aldehyde. Acid halide is converted into aldehyde. So now this acid halide can either be aliphatic or can be aromatic. That means it can be RCOCl or it can be C6H5COCl or any other aldehyde. The higher ones also you can take. So basically what you are taking here is you are reacting this with H2 in the presence of palladium, barium sulfate. You reduce the reactivity of this by poisoning it. It is poisoned with sulfur, or in some books instead of sulfur they write quinoline. So you poison this with sulfur or quinoline, and the name of this catalyst which we are using is Lindlar's catalyst. It is Lindlar's catalyst. So Lindlar's catalyst reduces, it's basically a reduction reaction, reduction of acid halide to aldehyde. So how the reaction occurs is, if you write down with say CH3COCl, you will react this with H2 in the presence of the same palladium, barium sulfate, poisoned with sulfur. You will write down poisoned with sulfur or quinoline. So in this H, one H you'll write here, one H you'll write here. So what products you get? CH3CHO plus one H with the Cl will form HCl. So if I am writing with this, it's simple now. One H you'll write here, one H you write here. That means with this you are getting benzaldehyde and HCl. Benzaldehyde and HCl. Now suppose, what is this? This is benzoyl chloride. From benzoyl chloride you are getting benzaldehyde. This is acetyl chloride or ethanoyl chloride. You are getting acetaldehyde. Now what if I take HCOCl? If you name it, it is methanoyl chloride. Methanol, one carbon, methanol, or formyl chloride. If you try to carry out this reaction in the presence of Lindlar's catalyst, it should be forming H and H. It forms H. If you're taking HCHO and HCl, no, this reaction does not happen because this formyl chloride which we have taken is very unstable. You cannot carry out this reaction. This, suppose you are asked like this, formyl chloride in the presence of palladium, barium sulfate poisoned with this, you cannot carry out the reaction directly because you cannot have formyl chloride as such. It is always prepared in C2. Formyl chloride is always prepared in C2. In C2 means within the reaction. You'll use two reactants to form this formyl chloride. So within the reaction, this will be formed, not separately. Clear? So this was Rosenmund's reaction. The next reaction which we are taking is Stephen's reduction reaction. It's also quite important. All name reactions are actually very, very important. Now in this what happens is cyanide. You're taking cyanide, SnCl2, HCl, and you get this as the intermediate product. This is called as imine, and you carry out hydrolysis. On hydrolysis you get aldehyde. This is the reaction you will find in NCERT. Okay, now let us see how this reaction occurs by talking about its mechanism. So we will consider the mechanism of the Stefan's reduction reaction. Now what happens in this is you take SnCl2 and the reaction is in the presence of HCl. Actually, when you balance it, you get 2 moles of HCl, right? So what you are getting when the two react is at this and this, they'll form SnCl4. And then you will get here 2 nascent hydrogens. Okay, the reaction has occurred. Mechanisms are always proposed later on. This would have happened, in carrying out the reaction. It's just a proposed thing. So in this, what is happening? Sn2 plus in this oxidation state is 2 plus is getting oxidized to Sn4 plus. That means 2 electrons are lost in this. 2 electrons are lost. Now let us take this cyanide. This has happened in the catalyst itself. So suppose I take CH3Cn. Okay. If I take this, then carbon in comparison to carbon, nitrogen is more electronegative. So this will try to pull the electron pairs towards itself and get negative charge, and the carbon gets positive charge. This gets negative, carbon gets positive. That means these 2 electrons which were lost by this particular reaction, they are going to attack on the carbon which is positive. Now what changes I made here, I am going to represent in the next structure. This carbon, now it is only a double bond because one of the bond has gone this side to nitrogen. So here nitrogen is having a negative charge and these 2 electrons have occupied this particular carbon. Okay, so when this has gone, these 2 electrons have gone, so this also now gets a negative charge because of the 2 electrons. Okay, now this 2 H plus which were obtained here. So these 2 H plus, now they are going to attack both carbon as well as nitrogen. Right? So they are going to attack both carbon and nitrogen. So when they are going to attack both, what will happen is CH3CH. Now it's a double bond here already, then NH. This was the intermediate product which is called as imine. Now in this also further, when water hydrolysis is occurring here, that means I'll write down water. Now in this there is a double bond, 1 sigma and 1 pi. Again we know this is more electronegative, so this will try to attract the pair towards itself. So this is negative comparatively and carbon is positive. So this water has H plus and OH minus, of which the positive part will attack nitrogen and the negative part will attack the carbon. So what changes are there? I'm going to represent here. So this negative part will get attached to carbon, and here you have this hydrogen getting attached as a double bond. So we will write like this. This one of the bond has shifted here. So because of this it got a negative charge and the carbon got positive. And what changes I have made, I have shown here. Now what happens further in this is this NH2 is a better leaving group. It is a better leaving group, so it will try to take this H towards itself and again try to get one negative charge. This is more electronegative. Again it will try to pull this bond between carbon and nitrogen toward itself and try to get one negative charge to satisfy this negative charge. So H from the neighboring. Now why neighboring? When this comes here, the valency of this carbon is disturbed. When the valency is disturbed, the neighboring oxygen hydrogen bond shifts here in between carbon and oxygen to satisfy the valency of carbon. Now H is left over. H shifts with this and liberates ammonia. So what exactly happens is this H comes here, means it is going to form ammonia, and this has gone and double bond has come here. That means you will have CHO. Okay, just once again I'll explain it. This was cyanide. This was first the catalyst. In the catalyst, H plus was generated and stannous has got oxidized to stannate. So 2 electrons were lost. Every time this nitrogen being more electronegative tries to pull one bond towards itself. So because it pulls electron, this carbon gets positive, so both electrons they come on carbon, this gets negative, this has already got negative by pulling the electrons. So both get negative, both the H plus will get attached to carbon and nitrogen. So you get imine. Again this is more electronegative, it will try to pull the pi bond towards itself, this gets negative, carbon gets positive. On hydrolysis, N will get H, carbon will get OH. Again this is more electronegative, will try to pull the bond towards itself, will now get a negative charge, will pull H from here, liberate ammonia. To satisfy the valency of this carbon, the double bond is formed between carbon and oxygen by pulling this bond down. Okay, so there are some more methods left for the preparation of aldehydes we will be taking in the next lecture. Till then, please practice all the preparations of aldehydes and some common ones which we have discussed in this video. Thanks for watching.